another Daily Dr. Racket. This is Wilson. We start off where we left yesterday. I feel very tired today. It's Sunday. I have had some food, but it's getting warmer, and I seriously don't like warm weather. I wish for winters to return. I love winters, man. I'm a winter person, so southern hemisphere and southern countries are not my cup of tea. The weather that I want maximally in summer should be 20 degrees, 20 degrees, and that's it. But here it's going to be 40 degrees, so there isn't much we can do. So I hate summers and I hate Sundays, and I don't think I have slept very well. But enough of me ranting. So we start where we left off yesterday. So now basically we wrote all these functions. We saw what a function is, which is function definition, and you have function application. And basically if you have this, so here you define the function, and function definition takes, here you have the input name, here you have the name of the function, here you have the input name, and here you have the body of the function, and here you have function application, where you have the function name and you have the argument here. And so basically we made this function because we wanted to predict this value, which is 100, because it's just x squared. And so then we go on to the next. We quickly mentioned it in the previous section. When you are into interaction area like this, empty scene 160, Dr. Racket produces an empty rectangle, also called scene. You can add images and scene place image. Okay, they're using a rocket here. When you type it into interactions area like this, Dr. Racket produces an empty rectangle called scene. Dr. Racket, so basically we're going to draw this empty scene. I don't know if I should remove all of this. I need the rocket image, so let's keep that. So let's draw an empty scene. I can delete this part. I can delete this part as well. I don't really need it. I usually save all of this, but now that it's saved in the video, I can just look back if I need to. 100, 60. So here you have empty scene, and that's the math we did on the rockets. So let's delete that as well, just for the sake of clarity, or just comment it out with the box. I'll copy and paste this here because we're going to use it. Copy, paste. And let's comment out with the box. Actually, it's better to comment it out than to remove it completely. So comment out with semicolons. Let's see. Now you have an empty scene here. Control R. Yeah, but it by default prints the image. So then we have place image. Now we have to place image in here. I think the rocket is really massive. It's not going to be able to. So we might have to draw a larger empty scene, but let's try. Place image. The rocket. Why do I have to select the whole thing? Cut, paste. So it's trying to place it in center. but I don't think it would work. 50, 23, empty scene, 100, 60. Now here's the problem. I told you, like, the rocket would not fit. So do we know, if we want to, like, we'd have to make the empty scene, like, image, like, think of the rocket as an object, it's a dot and above table. So let's look at image height and image width. So in order to make our, I mean, it's not necessary to draw like a accurate it's not necessary to draw an accurate image, but image height, Control R, it's 233, and same can be done with image width. So now 233 and 217. So we can do this as 233 and let's make it 250. Let's make it 300. Just a tad bigger, and then this 50, 23. So that's like approximately half. So 150. But I don't think it will work. So let's make the triangle twice as big. 400. And 200. Let's try this now. But it'll be very big. No, it's not at the center, but still, it's like completely destroyed from the top. Place image at, but it has to be at the center. So it's like an interesting question to solve. So you had it as 50, 23. So that's at the midpoint. So the midpoint of this would be around 200. This is empty scene, so the midpoint is 200. And this is 23. So what's that for 60? It's around, almost around the center. Let's try to do 100. So yeah, see, now you get it at almost right at the center. It's not exactly at the center. Let's try to increase the height a little bit. Yeah, these questions are fun to do. 500. I think the width is still okay. No, it's made it wider. Yeah, 400 and 300. Yeah, now it seems okay. Like, let's do this 500 and 400. Now it's really massive. The tip is still like, the tip is just not yeah, it's near the tip, like I think 500 and 400. I think this, the y-axis is just like 500, 200. No, it's 500, 300 is better. But what we need to do is we need to push it more towards the center. So we do this as 150, more down, because as we saw, it's top to bottom, and now we see perfectly at the center. It's not supposed to be at the center, I mean, but still, and just to make life a little bit easier, we delete this and we delete this as well, or we just like comment out with semicolons. So now you see it's not actually placing it at the center, but This is why you need to be good at math to do this kind of thing. Think of the rocket as an object that is like a dot in an above table from your mathematics class. Can we shorten the image? Because that'll make life a lot easier. Probably not. Not in this one, no. The next you should make the rocket descend just like the dot in the above table. That's what we did actually. From preceding section, you know how to achieve this by y coordinate supplied to place the image. Oh, this is interesting actually. So 160. So they are basically manipulating this. Actually, you know what? Let's just delete this. We had the values here. So just for reference, I'll put them. Let's call this height. Let's call this height. And let's call this width. And then that's probably what it is, image height and image width. So now we need to copy this, paste it, and we need to bring it down. Let's start with 200, although it will be 200, 200. 200 to 200. We have to reduce it because it's going down the y-axis. 200, 150. Let's try it actually. Here, yeah. So we start with 200, 150. Let's go with 250. So is it going down? So we start with, oh, it's going to, yeah, so 250 would be like it's pushed out the edge. So instead of 250, I don't know, 300 would be just out. It's just like I need to like increase this as well. So it's at 200, but let's just make it 400. 400. Make it 400. Control R. Oh man. So this is shifting it this side. Oh, actually I should. Oh no, let's just. I think empty scene this I can make it larger. So this is why you need all the linear algebra. I think I can make it a little bit wider. Let's try 600. Okay, it's too big. Oh no, it is there. We see it here. Yeah, now it's 600 is pretty good actually. So I can make this shorter. But that's not what they do in that one. Oh, yeah. Oh no, I think 500, 600 is still okay. Now let's just go to 300. And let's just go to 400. Yeah, let's start with 500. 200, 500. Yeah, so now it's right at the bottom. I think 500 is still too much. I'll start with 400. I pressed Control E. We start with 400. So 400, a little bit more down, 450. So we are going down the y-axis. 450. Oh man, I wanted to touch this surface. 470. 490. let's see, 470. Yeah, I think this is as good as it gets. 470, 490. I'm looking at this one first, but it's actually this one. Yeah, 470 is as good as it gets. So we go from 470. I think I should start with 470, 450. 450 is as good as it gets, actually. I think. Yeah, 450 is as good as it gets. 450, then we go to I think the image would, if it was shorter, then probably I'd 450, then 500. Oh no. Oh, it has to be a little bit. It has to be a little bit less actually. So this is probably 400. You can see me 450, 400, and this is probably. This is less, 500, 600, 450, 400, 300. Let's do this 200. Now we are almost at. Can I make it separate? So you go from here. The rocket has a long way to travel. It's getting closer to the edge. I probably can. And then we do one more time. This was fun, actually. And then we go for 500, 600. Oh no, here's 200, 200. And now we have 300, 200. Almost there. Is it to 300, 200? So we went from 450, 400, 200, and 150. I just shifted it. I just shifted it along the wrong axis. Yeah, it's almost there. So let's see. We start from here. I can copy and paste them in reverse order actually. So it could be something like this, then this. Oh, waste of time. Yeah, I am wasting my time a little bit, but it's fun. I think you get the idea that we are. So now we are progressively increasing the value. 150, 200, and what are these guys doing? 20, 30, 40. Yeah, they're. All that's needed now is to produce lots of these scenes easily to display them in rapid order. The first goal can be achieved, of course. See figure 4. Where is figure 4? Is this figure 4? Or no? Oh, this figure 4. I can actually just press it. But let's run our film first. The first goal can be achieved. Yes, this is a function definition. So let's try to run it. Control R. And there you go. Woo. Yeah. It's cool. It's really cool when you think about this, you know, like the math can explain so many things, math and like computer science. It's just like the first goal can be achieved, the function, of course, see figure 4. Yes, this is a function definition instead of instead of Y, it uses the name of picture rocket, a name that is immediately tells you that the function outputs are seen with the rocket. Instead of X, the function definition uses height for the name of its parameters, a name that suggests it is a number and tells the function where to place the rocket. The body of expression of the function is exactly like the series of expression and what we just explained, except it uses height in the place of a number. So picture of rocket, this is a function and you input the height and then it places it on the empty scene. Okay. So you basically you convert this whole thing into a function. So define, can we do something, increase font size, use horizontal layout. I don't know if this will be better. For this, yeah, for this definitely this is better. But for other things maybe not. So let's try. Define picture of rocket. You have height. So it's basically now we convert this into a function. I think that's what this whole text blob meant. And that's the figure 4. So the goal can be achieved with the function. So what we just did can be converted into a function. And that is the interesting part. So we will do that. I don't know if it's necessary. I was looking at how much more there is, because let's finish this section and then we might end it. Place, and so we have used different coordinates. Place, image, copy, place image. I actually like doing this kind of stuff. 50 HEIGHT, empty scene, 160. So now let's just so picture of rocket, and we start with picture of rocket. How many are there? Yeah, I think the coordinates is going to be something like this, 500 and 600. You could see that here mine is wider and his is taller, mine is wider, but not by that much. So picture of rocket, and you keep one value fixed. So here the value that is fixed is this, which is always at 200. So instead of 50 we use 200. And here we can place the heights. So where we start, 450, we start at 450 and end at 450, 400, 200 and 150. 400, 200 and 150. First let's see if it runs, then I'll delete the rest. Oh yeah. Read syntax expected Yeah, that's why I first wanted to make sure if it runs. Okay. Oh man. So empty scene. Oh yeah, I missed a bracket. Sorry, my bad. So now it runs. Now, just for the sake of clarity, let's delete all of this or just comment it out. Let's comment it out. Comment out with semicolons. And now let's just run this. And we see a rocket. Yeah. It actually should be the other way around, so let's do this. 150, 200, 400, and 450. I should remove this indent, although I don't think it will. So now we go. That's cool. That is very cool, actually. The second goal requires knowledge about one additional primitive operation from 2 HTTP universe. Animate. So click run and enter the animate picture of rocket. Is it going to work though? Let's just try. So let's just comment these guys out first because I want to see if it actually works. Animate picture of rocket. Animate is not a function because I don't have that library here. Well, I do have it. Stop and note the argument expression is a function. Don't worry for now about using functions as arguments. Okay, animate is not a function. Okay. Let's have a look. Let's see if that's correct. Yeah. It does say that it's a function. Animate, create image. Well, that doesn't seem to be right. Let's try to uncomment this. Comment, and now let's try. Animate, this function is not defined. Okay. Well, we have the library here, require. This function is not defined. Define create UFO image. The second goal requires you to knowledge additional primitive operation, animate. So click run and enter the following expression. Stop. Yeah, you have this create UFO scene height. Yeah, so this is the problem. Like animate picture of rocket. So this does not seem to be correct. It's like it shows animate does work. Define UFO scene. Divide picture of rocket. Let's try to copy and paste this if it's actually going to work like this. Okay, so I mean, I don't know what's going on here. Let's try to put this rocket instead of that. But animate is not a function, so. Okay, so animate itself is not a function. Animate is not a function, Dr. Racket. Animations, what's wrong with my animate? Stack Overflow is your friend, so. Break up my takeoff function into smaller pieces. Figure out the problem, let me know. So maybe we didn't do something correct here. Don't know, I'll try to figure it out. But I am using it like this, like they say here in the docs, like define UFO underlay. So it's not that this function is not defined. So I don't know what's happening. And do HTTP is being, yeah. Background. Let's try to get through this first and then stop and note the argument expression. Don't forget to add to HTTP universe library to your definitions area. To HTTP universe. Okay. That's what was missing. It's actually quite cool. Yeah, see, but it's going. It's like touchdown. It's not going. It should stop somewhere. That was the error. Okay. As soon as you press so that was let's try to flip this actually. Let's see what happens if I flip it. 400, because it went from top to bottom. Let's see if it goes from bottom to top. Oh no, it's the same thing. Still top to bottom. As soon as you hit return, Dr. Racket evaluate. But it does not display a result, not even a prompt. It opens another window or canvas, which is what we saw, and starts to tick clock 28 times per second. Every time the clock ticks, applies a picture of Rocket to the result of these function calls are displayed in the canvas, and it produces the effect of an animated. The simulation runs until you close the window. The question you see here, you see that 262 there. The result of the function calls are displayed in the canvas and it produces an animated movie. So you have and so these are number of ticks that passed since function calls, and so it's 28 times per second. So we do the calculation for that. Simulation runs until you close the window. At that point, animate runs the number. The question is where the images on the window come from. There's this operand on the number 0, 1, 2, and so on. The question is where the images from the window come from. The short explanation is animate runs its operands on the number 0, 1, 2, and so on, and displays resulting image. The log explanation is animate starts a clock and counts the number of ticks. The clock ticks 28 times per second. Every time the clock ticks, animate applies function picture of rocket to the current clock tick, and the scene that this application creates is displayed on canvas. So animate starts a clock. Okay, I get that. So the clock is ticking 28 times per second. So every time the clock ticks, it applies this picture. Let's try something interesting. Let's comment this out. What I'm trying to do is make all of them now at the same position. So we are at, say, let's say at 200, and so let's see what happens now. Oh, it's the same thing. It is the same thing. So this position does not matter. Every time it applies the picture to the current clock tick. So basically it's just like every time it applies that picture, and that's it. This means the rocket at first appears at height 0, then 1, then 2, and so on, which explains why the rocket descends from top. So it's going to take the image, but it's always going to apply to, like, this will create an image, but then it would place it on the y-axis based on this tick, like clock tick. This is our 3-line program, creates 100 pictures in about 3.5 seconds. Displaying these pictures rapidly creates the effect of rocket ticks. So here's what you learned in this section. Functions are useful. So basically what's happening from what I understand, I read it out, but this is how I see it. It's basically making a clock tick. It's calculating every 28 seconds, and every 28 seconds it's generating an image. And then it's generating an image and it's placing it around the y-axis. In like 0, 1, it's like going down the y-axis like this. So it's like 0, 1, 2, 3, and it's been created every 28 seconds. So yeah. So here's what you learn. Functions are useful because they can process lots of data in a short time. Okay. You can launch a function by hands on few select inputs and ensure that it produces proper outputs. This is called testing a function. Yeah, testing basically means is the function producing the proper output. Dr. Racket can launch a function on lots of inputs with the help of some libraries. When you do running the function, naturally Dr. Racket can launch functions when you press a key on your keyboard. So yeah, it can do it on multiple inputs, like functions can be applied on one input or many inputs. And when you manipulate the mouse of your computer, so you can press a key or you can just press run here basically. So you can go here and you just press run, and then that'll do the job for you. To find out how, keep reading. What triggers a function application is, but do keep in mind that simple programs are functions. So basically, simple programs are functions, and basically that's the main idea behind this book, functional programming. So that's it for today. We'll continue this tomorrow. Like and subscribe. Stay tuned for more. Consider donating through PayPal, and peace out.